है उसको ग्रामीण विद्युतीकरण की असलियत हमको पता नहीं लग रही है, उसका अध्ययन करके बताया जाए। तो अध्ययन का बहुत अच्छा असर रहा। वर्ल्ड बैंक ने, अपना रूरल डिफिकेशन कॉरपोरेशन ने, IDFC ने, जर्मन गवर्नमेंट ने हम सबको मदद किया और अजमेर डिस्कॉम के माध्यम से एक स्टडी प्रतापगढ़ में हुई थी और उससे ये सिद्ध हुआ कि जन सहभागिता ही एक ऐसा उपाय है जिससे पावर सेक्टर क्या सभी सेक्टर्स में सुधार हो सकता है। मतलब ये कि सर्विस प्रोवाइडर और सर्विस यूजर दोनों का अगर पॉजिटिव एटीट्यूड हो किसी चीज को बेहतर करने में तो सुधर सकता है। आगे चल करके 2006 में विधिवत रूप से इसका गठन हुआ, तब से ये अपनी क्षमता के अनुसार जो कुछ भी संभव है वो अपनी भूमिका अदा कर रही है। मेन इसका है पॉलिसी रिसर्च एंड एडवोकेसी, इसका प्रथम ध्येय है। और इसके करीब हमारे अब जो हैं 65 के करीब मेंबर हो गए हैं, तो उन लोगों के सहयोग से ये चल रहा है। कुछ संगठन जो है हमको, जैसे उदयपुर चैम्बर ऑफ कॉमर्स है, भीलवाड़ा मेवाड़ चैम्बर है, इस तरह के चैम्बर्स भी हमको समय समय पर मदद करते हैं। और मुझे बताते हुए ये खुशी है कि हम जनहित के कॉज के लिए रेगुलेटरी कमीशन में तो जाते ही हैं, उसके अलावा किसी किसी मामले में हमको रेगुलेटरी कमीशन से संतुष्टि नहीं है तो एपेलेट ट्रिब्यूनल में जाना पड़ता है और वहां पर भी हमको हमारे साथी DP चिरानिया जी हैं, उनके सहयोग से काफी सफलताएं मिली हैं और राष्ट्रीय स्तर के आदेश जो हैं हमारी पिटीशन पे हुए हैं। इसी तरह से जनहित के मामले में हमको सुप्रीम कोर्ट भी जाने का अवसर मिला और सारी व्यवस्था को हमने बहुत नजदीक से समझा और ये पाया कि जब तक स्टेक होल्डर्स जो हैं उनमें एजुकेशन और अवेयरनेस नहीं होगी तब तक कोई भी सेक्टर नहीं सुधर सकता है। और वही स्थिति पावर सेक्टर की है। तो हमको बहुत अफसोस होता है कभी कभी कि जो हम एक्सीडेंट्स की खबरें सुनते हैं तो मन में बहुत पीड़ा होती है और वो सारी चीज इसलिए है कि लोगों में इग्नोरेंस है और इग्नोरेंस की वजह से नेग्लिजेंस हो रही है। तो पिछले 2 वर्ष में जो कुदरत ने हमारी परीक्षा ली है, लेकिन उसमें भी जैसा हमारे प्रधानमंत्री जी कहते हैं कि आपदा में ही अवसर ढूंढा जाए, तो हमारे DD अग्रवाल साहब ने इस अवसर का बहुत बड़ा सदुपयोग किया और वेबिनार लगातार जो है वो आयोजित करते रहे विभिन्न विषयों पर। अच्छे अच्छे वक्ताओं ने इसमें हमको ज्ञानवर्धन में मदद किया। उसी श्रृंखला में आज हम एक ये 2022 का वर्ष जो है उसका शुभारंभ इस वेबिनार से कर रहे हैं और ये विषय अपने आप में इतना ज्यादा महत्वपूर्ण हो गया है कि आज आप देखो गली गली में आपको स्कूटर्स नजर आएंगे बैटरी से चलने वाले। जिस स्थान में मैं रहता हूँ मानसरोवर में, तो वहाँ के मेन रोड्स पर तो लगभग पुराने जो ऑटो हैं वो बंद ही हो गए और केवल ये बिजली से चलने वाले, बैटरी से चलने वाले वाहन ही नजर आ रहे हैं। तो इसके महत्व को देखते हुए आज का ये वेबिनार रखा गया है और इसमें मेरे को बहुत खुशी हो रही है कि DD अग्रवाल साहब के प्रयास से और हमारे साथी सैनी हैं कैलाश जी, उनकी मदद से जो ज्यादा लोगों तक कम्युनिकेट हुआ है। तो मैं इस अवसर पर इस बात की भी बहुत एक खुशी आपके सामने व्यक्त करना चाहूंगा कि मेरे बचपन के साथी हैं डॉक्टर दिनेश जोशी, वो कादरी में इंडिया की नहीं बल्कि वर्ल्ड के माने हुए एग्रीकल्चर साइंटिस्ट रहे हैं, वो भी इसमें भागीदारी कर रहे हैं। इसके साथ साथ मेरे परिवार के जो हैं वो सदस्य वो ओमान से भी भागीदारी कर रहे हैं। आशीष पांडे मेरे सन लॉ भी होते हैं और वो बैंकर हैं। तो इस तरह से ये जो विज्ञान है इसका बहुत ही सदुपयोग किया जा सकता है। वो इस चीज से सिद्ध हो रहा है कि विभिन्न क्षेत्रों के लोगों को जो भी कॉमन इंटरेस्ट का इश्यू है उस पर हम एक साथ इकट्ठे होकर के बिना किसी भौतिक असुविधाओं के, अभी मैं देख रहा था माखीजा साहब को और भाभी जी को भी, तो वो भी इसमें उतना ही इंटरेस्ट से भागीदारी कर रही हैं। तो ये विज्ञान का एक बहुत बड़ा सदुपयोग है। तो मैं इस अवसर पर और आप सबका अधिक समय न लेता हुआ पुनः यह निवेदन करूंगा कि आप लोगों का इसी तरह से सहयोग और उत्साहवर्धन बना रहे, तो समता पावर जो है अपना जिस लक्ष्य से गठित किया गया है उसमें ये भूमिका अदा करता रहेगा। और हमें उम्मीद है कि हमारे पावर सेक्टर की जो बड़ी बड़ी व्याधियां हैं, जिनमें सबसे पहले मैं मानता हूँ एक्सीडेंट्स, दूसरा हमारे एटीएनसी लॉसेस, तीसरा हमारा जो रेवेन्यू डेफिसिट है, उनको कम करने में हम सभी लोग मिलजुल करके, और रेगुलेटरी कमीशन से भी हम आग्रह करेंगे कि वो भी अपनी एक जो सक्रिय भूमिका अब तक निभाता रहा है वो निभाता रहेगा। और मुझे इस अवसर पर ये बताने में भी खुशी होती है कि हमारे आग्रह पर रेगुलेटरी कमीशन लगातार अपने आदेशों में एजुकेशन एंड अवेयरनेस का डायरेक्शन बराबर देता जा रहा है। मैं ये भी उम्मीद करूंगा कि हमारे जो डिस्कॉम के साथी हैं जो मैनेजमेंट में, वो इसके महत्व को समझेंगे। और जो बिजली चौपाल, एक तरह से ये समझिएगा कि वो उसमें एक मेरा ही विनम्र शुरुआत थी पाली में, जब मैं सुपरिटेंडेंट होता था तो बिजली चौपाल नाम से एक कार्यक्रम शुरू किया था, और उसके बहुत अच्छे नतीजे आए कि हमारे उपभोक्ताओं में और कामगारों में पॉजिटिव और हेल्थी तारतम्य बैठ गया था। उसी को पांडे साहब जब चेयरमैन थे, उन्होंने आदेश के रूप में इसको प्रसारित किया। लेकिन विडम्बना यह है कि जैसे सरकार में प्रशासन गांव की ओर जाता है, प्रशासन शहरों की ओर जाता है, लेकिन वो आत्मा जो है वो अपने दफ्तर में या घर पर टांग के जाता है, तो उस मुद्दे से कौन बात करेगा। तो वही स्थिति हमारी इन चौपालों की हो रही है। तो मैं इस अवसर पर इस मंच के माध्यम से हमारे डिस्कॉम के जो भी साथी इसमें शरीक हो रहे हैं या जो आप सभी स्टेक होल्डर्स में शरीक हो रहे हैं, उनसे अनुरोध है कि अगर हमारा एक जीवंत सतत संवाद होता रहे तो हर चीज सुधर सकती है। और जो एक औपचारिकता के रूप में रेगुलेटरी कमीशन से भी जब एडवर्टाइजमेंट निकलते हैं तो उसमें भी लगभग जीरो भागीदारी होती है, तो वो भी सुधर सकती है। हजारों लाखों रुपए खर्च होते हैं, उसके बावजूद भी जनता का फीडबैक नहीं जाता है, तो रेगुलेटरी कमीशन में भी एक निराशा का भाव पैदा होता है, हम लोगों में तो होता ही है। तो मैं चाहूंगा कि हम सभी स्टेक होल्डर अपनी अपनी भूमिका अदा करें। और आज का जो विषय है इसके बारे में डीडी साहब ने बहुत तैयारी की है। आज सुबह भी जब उनसे जिक्र हो रहा था तो मुझे बहुत अचंभा हुआ कि डीडी साहब कितनी मेहनत कर रहे हैं, उन्होंने बहुत अध्ययन किया है इस विषय के ऊपर। तो मैं पुनः आप सबका स्वागत करते हुए ये निवेदन करूंगा डीडी साहब से, इस आयोजन को आगे बढ़ाएं। धन्यवाद।
धन्यवाद सनाड्या साहब। मैं चीफ गेस्ट हमारे मेन स्पीकर पधारे, उसके पहले मैं कुछ बताना चाहूंगा आज के बारे में। सर, today's webinar on electric vehicles overview in India is very important, as government of India have targeted 30% new sales of automobiles to be only electric vehicles by 2030. This will have a turnover of about 50,000 crore rupees. As you are aware that there is a high import bill with about 85% to 87% import content of petroleum products in country, having great dependence on other countries, along with commitment of country under COP26, जो वर्ल्ड कॉन्फ्रेंस होती है अपने क्लाइमेट चेंज के बारे में, जो भी COP26 हुआ है, उसमें हमारी गवर्नमेंट ने ये प्रॉमिस किया है कि by 2030 they will reduce their emission by 30% by 2030, and they will be carbon neutral, zero carbon emission by 2070. It is a very important to encourage promotion of use of electric vehicles. Electric vehicles is because electric vehicles is very important issue and its emission is very high in the sky. IC engine vehicles have efficiency of fuel use of hardly 30%. IC engine cars have only 30% fuel efficiency, while EV electric vehicle efficiency is almost 90 to 95%. Hence, carbon emission is very high from IC engine based vehicles compared to electric vehicles. Total carbon emission in world by car and trucks is 8 billion tons per year. This is about 20 to 25% of total emission. India is number 3 or 4th in the world in the emission of carbon. We are emitting in the world, maybe 3rd or 4th in the world. We are very highly emitting in the world. Sir, world over, electric vehicles and charging stations are being put in service in a big way. And many countries of Europe are now having more than 30% to 70% electrical vehicles. Norway is one country where the percentage is 70%. Their electric vehicle percentage is 70%. Government of India have also come out in big way to popularize electric vehicles and made new promotion schemes, along with various states who have also announced various subsidies and rebates in road tax, registration charges, etc. FAME 1 and FAME 2 are two subsidy schemes of Government of India mentioning subsidy and other benefits in electrical vehicles. All such details are available in government website e-Amrit. E-Amrit, a recently developed website e-Amrit, is a website of Government of India regarding electrical vehicles. This is a very important website giving all the details. It gives, which includes information on charging facility locations. Where are the charging facilities presently available? It is being updated on the daily basis. The new charging stations coming up at all the places are being named in the e-Amrit schemes. And then the EV financing options. Where can you get the finance for electrical vehicles? And government policy and available EV subsidies. Electrical vehicles पे क्या subsidies मिल रही हैं, क्या government की policies हैं, ये सब चीजें उस पे available हैं, which you can always look into it. A new production link incentive scheme, PLI scheme of rupees 10,000 crore for battery manufacturing in India have been issued by Government of India, giving impetus to local technological upgraded battery manufacturing. Besides the EV manufacturing, this PLI scheme has also been introduced for battery, upgrade the battery system, battery chemistry, because this is one of the important parts of the electrical vehicle. As regards four-wheelers, almost all big companies in the world are shifting their production schedule to electrical vehicles. Most famous is Tesla 3 of USA. This vehicle is in great demand, and there is a queue of 12 months to 15 months in the USA for this vehicle because of the chip shortage or because of the other restrictions. USA Ford, Tata, Mahindra, Hyundai, Renault, various models, Mercedes, BMW, Nissan, Audi, Volvo, Kia Solar, Porsche, Chapgos, Volkswagen, Praga, MKI, and many more China firms with their various models having different range of kilometers to run and having different charging time, battery capacity, maximum speed, or other specifications which every model specify, and prices are varying accordingly. Raja and Exide Industries have also registered for the production in India. Now they have also registered because they are the big battery manufacturers for this since long time. They have also come up.
तो दिखाया आशीष जी बैठे हमारे वेबिनार में। मैंने बोला था उनको मुझे बैठ जाना देखना छुट्टी है ना।
सनाटे साहब आपकी आवाज आ रही है, सनाटे साहब आपकी आवाज आ रही है, थोड़ा म्यूट कर दो सनाटे। In India there are number of electric vehicle 4-wheeler and 2-3-wheeler manufacturers. having number of models developed by Tata, Mahindra, Renault, Nissan, Maruti in four-wheelers, while Hero Electric, Optima Scooter, Ampere Electric, Bajaj Chetak Electric, TVS Electric, Ather Energy, and BGOS with various ranges and various models are already in market for two-wheelers and three-wheelers. While in e-rickshaw, Mahindra Electric, Hero Electric, Bajaj Auto, TVS Motor Company, and Loya Autos are big manufacturers with various models. There are already big manufacturing capacities available in India, and they are doing wonderfully well. The only limitation is the price of the battery. This is causing great harm currently to the promotion of the electric vehicles. Similarly, in trucks and buses, companies like Ashoka Leland, JPM Auto, Tata Motors, Olectra, Green Tech Limited, Deccan Auto Limited, Solaris Bus and Coach Limited, BYD Company Limited, Eicher Motors are main electric vehicle bus and truck manufacturers. There are 20 million electric vehicles world around. Today, there are 2 crores vehicles which are running, and half of it is in China. China having maximum numbers. Europe is about 20 to 25%, and rest of the world, balance in the rest of the world. Tesla alone sold 1 million units of car last year, and they are still in the great demand. There is a very big queue for a Tesla model. Indian market is also showing great demand of electric vehicles. So far, in first half of 2021, I am giving the data of 2021. It is 1.28 lakhs in the first half of 2021. This year, worldwide, 64 lakhs EV has been sold, and half of it is in China. As such, we see tremendous potential in electrical vehicle market in our country. In the present scenario, high cost of electric vehicle, four-wheelers, two or three-wheelers is on account of high cost of battery, which is about 40 to 45% of vehicle cost. More and more research and development is going on in battery chemistry in various IITs and other research institutes. Or research institutes like IIT BHU have done a great work in battery chemistry. They are putting up best of R&D to ensure that how the battery weight is reduced, how the charging time can be reduced, how the charging speed can be increased. All these many factors is taken into consideration. EV is facing challenges due to first is the challenge India is facing is that Government of India have set a target of 30% of EV sales by 2030. This is a big challenge, and industry and every research and development institutes have to take a call for it, because 30% is a very big number. Because there is a you have to develop the liking, you have to develop a demand for it, because of the price, you have to become competitive in the market. Now, the other challenges which we are facing in the electrical vehicle is a wide gap between electric vehicle and ICE vehicle prices. Prices are like Tata vehicle, which is very common in market today, is sold at about 13.5 lakhs, while the same petrol diesel model is about 6 lakhs. So it is double the cost. So you think twice before, unless you have something different. Your run is about 100-150 kilometers per day, and then you have to see how much the battery will work, how many years it will work, what is the charging time, whether you have to put up it for the whole night or whether you can do it in 2 hours. So many factors matter. Then the range anxiety, that's what I mentioned, that whether it is 200 kilometers, in one charging, it will go 250 kilometers, 150 kilometers, 250 kilometers. This is the range anxiety in the electric vehicles so far. Then the lack of charging infrastructure. So far, not many charging stations have come up in country. Recently, I have read that Indian Oil Company have promised that they are going to develop 10,000 charging stations in their petrol pumps in next 3 years. 1,000 they have already started. Government of India have also come up with every state has been made a nodal officer in every state and they have to ensure that charging stations are made in the gardens, in the local authority. They role to make the charging station available at the nearest point, so that there is no problem like petrol pumps. Because of the petrol pump, one can go up to 350 kilometers or so in a time.
डॉक्टर अशोक झुंझुनवाला ज्वाइन कर लिया था उन्होंने.
अच्छा सर, I welcome sir. Just a minute sir, I welcome. That's how I welcome you sir.
Namaskar. Namaskar.
Doctor. Welcome sir. Welcome sir.
Namaskar. I'm been waiting. I'm just all right.
Yes sir. Thank you sir. Well, just 2 minutes more sir. Sir, some of the challenges which I was mentioning about the Indian market in the electrical vehicle is wide gap of price between electrical vehicle and IC vehicles. The range anxiety, lack of charging infrastructure, lack of assurance about satisfactory resale value, lack of models choices, lack of availability of batteries, heavily dependence on imports, especially Leon batteries and ceramic material, lithium, cobalt, etc. Seventh is the success rate of other types of batteries based on sodium, aluminum air batteries and vanadium redox flow batteries. Viability of new battery swapping policy announced by Government of India in budget. Proper implementation of retrofit electric vehicles and viability of hybrid vehicles. These are the possibilities. The hybrid vehicles are being very commonly now being used, because you can use petrol, diesel, and at the same time you can have the electrical battery operated vehicle also. And that is retrofit, is that your present vehicle can be retrofit with a battery and motor, so that you can use it as a electrical vehicle. That is the policy Government of India have also announced. They have also announced some agencies where these can be done by authorized agents. Electrofitting can be done by. Viability of new battery swapping policy announced by Government of India. Proper implementation of retrofit EV and viability of hybrid vehicles. Impact of e-mobility charging stations as power load on grid stability. This is also a very important issue, because when you have number of vehicles having the battery, then the charging stations will come, then what will be the grid stability on increase in the power load. Then we have the RE capacity to be used for e-mobility battery charging by smart charging. That new concept for smart charging have been developed, wherein the charging of the battery could be done by smart charging. Then the recycling of large number of batteries and revival of lithium and other materials from the scrap. That is also, you have to develop new capacities for the use of scrap and revival of lithium out of it. What is the advantage? Advantage, I see that there are 2,000 moving parts in the IEC engine, while there are only 20 parts. Easy to maintain. Possibility of e-mobility batteries used as storage of RE capacity. This is also being seen as a very profitable and very good proposition, that batteries could be used as a storage at a time. This is just a learning stage, and probably this will come up in some time, because they say when you have a number of vehicles in a mall or in a something in a complex, but 200 vehicles are there, they can be charged at one time, and then in the night they can give the back to the grid. That is how the storage could be used. Already Government of India have announced complete triangle Jaipur, Delhi, Agra NH to have complete charging stations, and new charging stations throughout the country is coming up at various strategic locations. Reliance has agreed to put up charging stations at all Apollo outlets, tire outlets. Local bodies are also developing the stations, as Government of India have recently on 14 January, they have announced a new policy for the e-mobility. They had announced in the 220, they had announced earlier also, but latest they have developed in 14 January a new policy which will give impetus to the charging stations and e-vehicles. Popularizing electric vehicle will also help in big way use of green energy being used in charging stations, and new charging stations at various locations needed urgently. This is all my view on this. Now I would request
हाँ उनको कहो जरा उनको
Mr. A.K. Sharma. He was working with the Chief General Manager in the RICO to just introduce briefly Dr. Ashok Jhunjhunwala. He is not new to me, new to us. He is a great research and development person. He has developed IIT Madras to a very high level. We are incubation center, excellence center, and many R&D with the academia, with the industry is going on. And it's a really worth visiting once, and great work he's doing. He's in charge of all this, and he has developed a course for the electric vehicles, which is online with NAPTEL and without any charge. This is a great thing. He's also developed a course for BTech students, and it is working in IIT Madras also. I would request A.K. Sharma Sahab to briefly introduce Shri Dr. Ashok Jhunjhunwala Sahab. A.K. Sharma Sahab. Unmute करें सर. सर A.K. Sharma Sahab unmute करें.
Okay, sir. आवाज आ रही है?
हाँ भाभी.
Good evening, sir. I am A.K. Sharma. I welcome all. Ashok, I have to introduce Dr. Ashok Jhunjhunwala. Jhunjhunwala साहब प्रतिभा के धनी पद्मश्री डॉक्टर अशोक झुंझुनवाला का समता पावर मंच पर पुनः स्वागत है. हम सभी आपके परिचय से अवगत हैं क्योंकि ये इनका दूसरा वेबिनार है. मैं संक्षिप्त में आपने और क्या-क्या नए कार्य इस समय में किए हैं उसका छोटा सा विवरण प्रस्तुत कर रहा हूं. जैसा कि आप सभी को विदित है कि डॉक्टर झुंझुनवाला ने आईआईटी कानपुर से इलेक्ट्रिकल इंजीनियरिंग की और यूएसए से एमटेक किया है. आप प्रारंभ से ही अध्यापन का कार्य कर रहे हैं. आप आईआईटी मद्रास इलेक्ट्रिकल इंजीनियरिंग डिपार्टमेंट के प्रोफेसर एंड हेड हैं. ही इज अ pioneer in technological innovation in new and futuristic technologies which directly impact citizens and economic development of the country, especially the developing country like India. And few examples of his contributions are innovation in telecom sector, codec wireless loop for telecom networks with integration of both voice and internet services. He is a pioneer in such telecom sector. Number two is innovation in electric vehicles, which he will further enlighten us today. Innovation in solar decentralization is another, the solar which what we see today is a big contribution in this. He has set up a IITM research park, and there are more than 65 R&D centers of industry. It is a unique center, best in the country or maybe one of the best in the world. He is a director on number of public sector companies, chairman, member, and advisor of various government of India ministries and large number of corporate houses. He has more than 27 patents and research papers in his name. Now, more feather in his cap, IIT Madras jointly with NPTEL, National Program of Technology Enhanced Learning Courses, and Indian Institute of Sciences has developed and launched for 593 online certification courses free of cost for skill development, especially for electric vehicle and solar power, and also the special course of BTech courses for electric vehicle and solar power. His work has been well recognized by the country as a Padma Shri. He is a Shanti Bhushan awardee, and there is a countless, there are at least 5, 15, 20 awards he has got. So there is a long list. So such a versatile and such a knowledgeable person with us. Now I request Dr. Ashok Jhunjhunwala to enlighten us on today's topic. And I request Dr. Jhunjhunwala, please give more valuable your input, which we can help the industry and all the people present here. Thank you very much.
I need my sharing of screen to be enabled. Somebody has disabled my sharing of screen. I'm not able to share my presentation. Yeah, now I'm able to.
Okay.
Okay, I presume you are able to see my screen.
Yes, sir.
Yes, sir. We see it.
So I'm going to give a presentation with India point of view, electric vehicles. What are the strengths, weaknesses, what has gone on roughly? I heard this talk that was going on a few minutes earlier, and a significant amount of things was said. I'll just add to this. First, I'll start by talking about why is there so much interest in electric vehicles? There are two basic reasons. First reason is 14 of the 20 most polluted cities in the world are in India. And they are due to the petrol vehicles, whether we like it or not petrol and diesel vehicles. Number two, the import bills on oil has been going up and up and up and up, like anything. In fact, I have put numbers only till 2015, but it's gone up even further. Huge bill. In fact, it significantly drains our economy. On the other hand, one of the important thing about electric vehicle is that it is 4 times as energy efficient as internal combustion engine. Excuse me, somebody is talking in the background. Please mute yourself. So electric vehicle is 4 times as energy efficient as internal combustion engine, and it has 50 times less moving part. For example, internal combustion engine has a basic efficiency of 20%, 22%, 23%. Whereas for electric vehicle, motor starts at around 90%. This electric vehicle, if you really start using, our oil dependence will go away. Where is then the main problem? What is the main challenge? As we talked about a little earlier, the main challenge is that the battery. Let's talk about what is called energy container. Now, energy container in a petrol car is the fuel tank. In a similar manner, energy container in an electric vehicle is a battery. It can be charged. You can put charge in it and use the charge. It is electric charge that will drive the vehicle. So battery is like a container, like a fuel tank. Battery is like a fuel tank. But if you compare a battery and a fuel tank, battery is 8 to 10 times heavier for the same range of electric vehicles. So fuel tank is light, battery is so much more heavy. What does the heaviness do? It drives up the cost, this battery, size of the battery, and weight of the battery. So all three things go up for the electric vehicle. The weight goes up, the size becomes large, and the cost goes up. The second basic challenge with electric vehicle is the battery charging infrastructure. I have enough petrol pumps, I can go and get it filled in 3 to 4 minutes. Anywhere, petrol. I can't do the same thing for electric vehicles. First of all, the infrastructure is not there. Second, you cannot, like petrol, you can fill in 3 minutes. Battery cannot be charged in 3 to 4 minutes. This is an issue that I will talk about it further. Now, basically, the third challenge, which is a related challenge, new batteries are improving the energy density, gravimetric energy density. And yet, if I look at the lithium-ion battery, the energy density is somewhere here. Very, very low. And kilowatt hour per kg is even less. Whereas that of petrol and diesel is way up here. So that is basically we are talking about for lithium-ion battery, something here, and petrol and diesel is out here. So basically, as this improves, this is improving. There are other batteries, other things which are improving, and it will reduce weight, size, and cost. But yet, The distance is so much that this distance is going to remain. For example, the energy density today of NMC and NCSL is about 250 to 300 watt-hour kg. Today, you can even get 310, 320 watt-hour kg, 330 watt-hour kg. In near future, we will see high nickel content and graphite silica anode in a lithium-ion battery will make this around 400 watt-hour per kg. There are other variants. There are, like, for example, LFP battery. Their energy density is even less. They are being dumped today in India. But their weight will be more, cost will be more, and eventually the size, weight, cost, all three will be more. The second concern is, suppose we make this 250 to 300 to 350 to 400. Higher energy density, essentially you are putting higher energy density in small volume, and that has a higher safety concerns. So essentially there is a safety concern that keeps on coming out. But remember that 10 years back, the energy density was 80 watt-hour per kg, and today it is touching 310 watt-hour per kg. Now this is important. Of course, it has a higher safety concern, we'll deal with it. But as this increases, the price keeps on coming down. From 80 watt per kg, as it gone down to 310 watt per kg, the prices has fallen down to 110 dollars per kilowatt hour, or even less. This is the main driver of cost reduction. So we want higher energy density, even though there are safety concerns, because that is what over last 10 years has brought down the price by 8 times and is going to further reduce the price. So whether we like it or not, we want higher energy density. So what do you do with higher energy density? Well, strictly speaking, if you ask me, petrol energy density is much, much higher. And in the beginning, about 60, 70 years back, petrol was considered very unsafe, 80 years back. We learned to make it safe. In a similar manner, the lithium-ion battery with higher energy density is unsafe in a certain manner, but we have to tame it, we have to learn, we have to use engineering to make it safe, and we'll talk more about it. In future, costs and charging time may come down. Today the cost is high, charging time is high. It will come down. Size and weight will improve, but will be an issue for a long time, because today it is so much more that it is going to continue to be an issue. You will see the battery changing. Today you are using lithium ion. Tomorrow you may use lithium air, lithium metal, solid state battery, lithium sulfur, or even sodium ion. And then zinc air and aluminum air flow batteries. All this will improve things. And in 7, 8, 10 years, you may even say lithium ion batteries may be replaced by hydrogen fuel, generating electricity and driving electric vehicles. This will reduce the weight and size considerably. But frankly speaking, today, hydrogen fuel cost per kilometer as compared to lithium-ion battery will be almost 10 times higher. And that is not going to go down fast. So it is many, many years, probably never will happen, because lithium-ion battery cost will keep on coming down. Hydrogen is therefore a huge challenge. I would like to first give you in context of what is global focus and what is India's requirement, India's focus. Global focus is large vehicles, cars costing $30,000, $40,000, $50,000, which is like starting with 20 lakhs rupees, 30 lakhs rupees, 40 lakhs rupees, and large trucks in city, small trucks and long distance trucks. The focus internationally is, can I go 300 kilometers before I recharge? Can I go 500 kilometers? And they are looking for fast charging, 10 minutes to an hour, maybe 10 minutes. India's requirement is somewhat different. I've given you the vehicle breakup: passenger vehicle, commercial, three-wheeler, two-wheeler, and grand total. And if you see the majority, almost 80% of the vehicles are two-wheelers. 80% of the vehicles. Three-wheelers have also are increasing. And it will be the main last mile transport. And cars is small, only about 14%. And even amongst them, if you take premium cars costing more than 10 lakhs rupees, it is only 15% or 14%, so only about 2%. So the 2% of Indian vehicles compare with the European and American vehicles. And we very often just blindly follow them. 2% of our vehicles will be the premium vehicles, and they will require 500-kilometer long range. But for our other vehicles, you will see 200 kilometers is more than enough. We'll come to these things as we go on. So what should be the India's EV strategy? India's EV strategy has to be two-wheeler, three-wheeler, and small four-wheelers. They should dominate. Price point here has to be much lower than in the West, as it is driven by affordability. Can India get leadership in designing and developing these affordable vehicles? It has done it for ICE vehicles. ICE vehicles are very, very cost-effective. Our two-wheelers are very cost-effective. Our four-wheelers are very cost-effective. We can do that if we design and develop every subsystem in India and manufacture that. I'll come back to that in a later. Premium four-wheeler, which is 2% of the vehicle, large vehicle with 500-kilometer range, they are similar to the West. We don't mind learning from there. We don't mind importing. Let's not focus on this 2%. Let's focus on 97-98% of our vehicles. So what is the way to make low-cost electric vehicle? The strategy for low-cost electric vehicle is to reduce energy per kilometer. EVs without battery cost less than the ICE vehicle. ICE is the petrol vehicles. And electric vehicles, petrol vehicles drivetrain can easily get replaced by EV drivetrain. That is not expensive. The cost is in battery. Whereas there is a low-cost petrol tank, the equivalent empty battery or charged battery is expensive. And that is where it is. Battery is extra cost in electric vehicle and is a dominant cost. What if we increase the energy efficiency of the vehicle, electric vehicles? This Kitna Deti has slogans for electric vehicles will be kilometers. For petrol vehicles, it is liters of petrol. Here we will say kilometer per kilowatt hour, watt hour per kilometer. Can we improve that? If we improve that, then the battery size goes down. If battery size goes down, cost goes down. So we have to design for India the most efficient two-wheeler, three-wheelers, and small four-wheelers for us to reduce the battery size. And once we reduce the battery size, cost will come down. And size and weight of the battery will also reduce, which will increase the energy efficiency even more. So the focus has to be two-wheeler, three-wheeler, and small four-wheeler, and increasing energy efficiency. How do you increase energy efficiency? You increase energy efficiency by improving the motor and controller efficiency, better tires so that rolling resistance can go down, better vehicle aerodynamics, and lower weight. So this is the key thing. The kitna deti hai for EVs we have to really focus on. Then what else you have to do? If you, let's say for a current vehicle, the battery size that is required for certain range without range anxiety is this much. If you increase the energy efficiency, the size will go down by 35 to 40%. You increase the energy efficiency by 35 to 40%, size will go down, weight will go down, cost will go down. And this is what is happening. For example, electric auto, when we started 5 years back, they used to consume about 80 watt hour, 75 watt hour per kilometer. Today, we are talking about 45, 50, 55 watt hour per kilometer. For electric buses, We used to consume 1600 watt-hour per kilometer. Today we are consuming 900 watt-hour per kilometer. And how do we get there? We get there by increasing motor and controller efficiency, better tires, better vehicle dynamics, and lower weight. Now, to make the public vehicles, and public vehicles are like your taxis and three-wheelers, more affordable, you can do one more step. You can split the battery into smaller size and start using smaller size battery. Your smaller size battery will cost less, but the smaller size battery will mean small range. So what do you do for the small range? For smaller size battery, you swap the battery. So use smaller range and swap the battery. Now swapping the battery, just like you go to a petrol pump to fill the battery, you fill the petrol, you go to a petrol pump and it will take your battery and put in another battery. Take your discharged battery and put your charged battery. If that happens, that can happen in a few minutes. No waiting time, just like filling petrol. And therefore, even though the range is small, you can keep swapping very quickly and move on. So that can enable you, particularly for a three-wheeler and for even a taxi. They don't mind twice or thrice in a day if they have to swap. It will take them few minutes. They are running around the cities. They can just go in and get the battery swapped. So this battery swapping is a very, very interesting way. Another advantage of swap battery. See, in India, one of the problem with the batteries do not work well at high temperature. Battery's ideal working temperature is 25 degrees centigrade. In India, temperature goes to 48 degrees centigrade. Now, if you charge battery at that temperature, the battery will not last long. And if battery does not last too long, your cost goes up once again tremendously. But if you swap the battery, you don't have to charge the battery at 45 degrees or 48 degrees centigrade. You bring the battery in a conditioned environment, maybe an air conditioner, and then take several hours to charge. Charge slowly after cooling the battery. Once you do that, the battery life will increase. So swapping of the battery has this advantage. There is a further advantage that you don't buy the vehicle with the battery. Battery will always be available as rental. Just like when you buy a cooking stove, you don't buy a gas cylinder with that. Gas cylinder is taken on lease. Gas cylinder comes in, the cylinder gets exhausted, you replace it. In the same way, battery, you lease it, you take it from there, and once you run out of the battery, you replace the battery. That is what so vehicle cost now will be much lower. In fact, lower than the petrol vehicle because you know battery. And operation cost per kilometer will be much less than taking into account the depreciation, interest rate. It will still be much less than that of a petrol vehicle cost. And you can make it highly affordable, and basically you get a capital cost of vehicle then become less than the petrol vehicle, and rupee per kilometer operation cost is less than petrol, diesel, and CNG. So the swapping enables you to do that. And now finally the swapping, we have been on it for last 5 years to demand for it. Unfortunately, it was not accepted, but only last year it was accepted. And now the standardization is going on, still getting delayed, but this will really make things take off in a big way. So that was one approach. We are saying we should never bet on one approach, particularly for private vehicles. I don't want to go on to a petrol pump again and again. So therefore, I don't want battery swapping. Even for my two-wheelers, I don't want to go for battery swapping again and again. So then you have to, of course, if you use large battery to overcome the range anxiety, like Tesla does for 540 kilometers, then the vehicle weight will also go up, efficiency will further go down, and your cost will go up. On the other hand, if you do small battery, you have a range anxiety. Even if you put fast charger, it takes 45 to 15 minutes. Very fast charge will destroy the battery. So, and as the temperature becomes higher, this is a bad thing to do. So what do? Suppose in a two-wheeler or in a four-wheeler, you have two battery slots. One is a fixed battery, say for a car 100 kilometer, for a two-wheeler 50 kilometer. Now most of the days in a car you don't travel more than 100 kilometers. You travel 25, 30, 40. Most people, even in big cities, don't travel. So 100 kilometer range will be okay. If in a two-wheeler they travel even less, 20, 30, 50 kilometers will be more than enough. Now this is most of the days. But there are some 5, 10 days in a year, 10 days in a year, where you travel more, you go a little longer distance. That's a time you load in an extra battery called range extension battery. You drive to a, let's say, a petrol pump, which will put in a second battery. Now you can, instead of 100 kilometers, you can go 200 kilometers. And after you have gone 150, 170 kilometers, if you have to go further, that's time again you go to the petrol pump, swap out the range extension battery and replace it. Then you can go 300 kilometers. Then again you can swap the battery and can go 400 kilometers. In India, rarely do we travel more than 400 kilometers. So 100 kilometer battery car will now work for 400 kilometers by a second range extension battery. And this swapping can be done in 5 minutes, 4 minutes. You don't mind when you're driving long, stopping a couple of times after every 100, 150 kilometers for swapping the battery. So that is the approach. Same thing you do it for two-wheeler. Whenever you have to go for a longer distance, you don't have to worry about it. You just add a second battery and then go there. And this is what is the second possibility. The third possibility is like the conventional approach. Choose larger size of battery. And you have to slow charge most of the time. Occasionally, you may have to fast charge. So that time you can take 45 minutes to 1 hour. Remember that that's going to impact the battery life. But if you're going to do it once in a while, it may not matter. Most of the time, suppose you take 150 kilometer, or how many times do we travel more than 150 kilometer? When we travel more than that, we will recharge it. But most of the time, it will work without that. The question, does it charge? Where does one charge the vehicles? Homes is ideal, of course. Overnight, you can charge it. Nothing better than that. What about public places? Yes, you can charge it. But let me go further into details. One second, let me look at slow. Okay. Now, where do you charge the battery? Homes, there is no problem. Overnight, you can charge. Slow charge is best. Temperature also goes down, it is best. Public charge places. What are the public places you should charge? I do not think it is a wise idea to charge public cars at petrol pumps. Petrol pumps are designed for a vehicle to come in and get out in 5 minutes. When you take an electric vehicle, you will require 1 hour to charge. And you start putting those vehicles inside the petrol pump will become too crowded. By the time you put 2 or 3 vehicles for 1 hour, the whole thing will become useless. You need, at petrol pump, you need to be serviced in 5 minutes. So swapping is perfect at petrol pumps. Petrol pump is not a place for fast charging or slow charging. So where do you do fast charging or slow charging? At home, at parking lot, at office parking lot. Cars are kept there for 3-4 hours, 5 hours, 6 hours, charge there. Or shopping center. You go there, you can charge in 45 minutes, 1 hour. Even a public parking place, even street parking place, there can be charging. You keep it for 45 minutes and an hour. But remember, you have to take at least 45 minutes to an hour. And petrol pump is a bad place to charge because it does not have space to park. Parking lots are better space. Cinema halls you can charge. Shopping centers you can charge. Those are places that you can charge. Do you need standardization? Of course, you need charger and battery need standardization. No swappable battery needs standardization. Sure, they need, because otherwise a charger will not charge a vehicle, or swappable battery cannot be used. But what standardization do you need? You need minimum standardization. For example, you need standardization of connector, plugs and socket. If you don't put the right plugs and socket, you cannot charge. Maximum voltage and current needs to be specified. You don't need to specify anything more than that. There is always a communication between vehicle and charger, and between charger and the electricity board, utility provider. That needs to be standardized. That's a protocol. Metering, of course, needs to be standardized because one has to build, build a customer. And the standardization should also say protection. There has to be a minimum, this kind of protection in the charger. Same thing about battery swapping. You need to standardize the connector, plugs and sockets. You need to standardize the communication protocol and maximum size. Nothing more than that. Nothing more than that. What is a slow charge or what is a fast charge? Very often it's a myth. People don't understand. For example, if you charge a 5 kilowatt battery at 1 kilowatt or 2 kilowatt charger, it's a slow charge. Whereas if 1 kilowatt battery you charge with 1 kilowatt charger or 2 kilowatt charger, it is fast charge. So it is not the charger which is fast charge or slow charge. It is a relative size between the battery and the charging rate. Are batteries capable of fast charge? Yes and no. There are cells which are expensive, which can be charged fast. Ordinary cells which you buy, inexpensive batteries for your vehicle, low-cost vehicles, if you fast charge the way with batteries, the batteries will not last long. And battery is the most important component, most expensive component. You have to replace it very often, and then the cost will go up like anything. A question was also raised. I heard the talk that was being given while I logged in. Is the grid ready for EV chargers? Now, charger and bulk chargers loads the grid. Is grid ready for wide proliferation? Most vehicles can be charged using slow charger. And a slow charger is 300 watt to 3 kilowatt. For example, I have a electric vehicle for 6 years. I charge it with a 3 kilowatt charger in my parking lot. A 3 kilowatt charger is like a air conditioner, little bigger air conditioner. So most of the grid is ready. If I want to add 1 or 2 air conditioner at my home, I don't have to ask the grid. Similarly, if I want to charge slow charge 3 kilowatt electric vehicle, I don't have to worry about it. Even your refrigerator doesn't consume as much. Washing machine consumes quite a bit. So electric vehicle charging is no more difficult, and grid is very much ready for that, for slow charge. Fast charge is different. Higher charging, distribution line may not be capable of giving such large withdrawal of powers. And certainly peak power requirement may be difficult to meet as more fast chargers used. So the problem is with only fast charger, not with slow chargers. That's where you have to probably manage peak requirement by using what's called demand management, using pricing, time of use metering. And also the communication protocol may limit, saying that, well, though the fast charger is capable of charging at 15 kilowatt or 20 kilowatt, currently you cannot charge more than 10 kilowatt. So it will become a not very fast, not very slow, somewhere in between. Okay. Use EV battery for grid storage. Enable EV to the grid. This is important. Tomorrow, as I use more and more solar and wind, I don't have 24/7 power. To meet the demand 24/7, I have to store batteries. I have to store power, store energy. Now, storing energy requires battery. Parked EV battery can be used for storing the power, excess power of the grid. So if I have a vehicle parked in my home or at my office, and there is excess power, my vehicle will be more charged. And when there is a deficit of power, it can be taken away. Of course, you have to put a limit that cannot go below this, because otherwise I won't be able to drive. So EV to grid is important, and we need to work on that. My next part of my talk. Very often it was said that electric vehicle threatens the GDP of India because auto sector is about 7.1% GDP. Transport, fuel, processing and distribution is 5%. So we will lose this 12.1% jobs as we move away from electric vehicle, from a petrol vehicle to electric vehicle. The question, will we lose jobs and our GDP? The question is, do we design and manufacture subsystems in India? Batteries, cells, materials, motors, charger, power converters, vehicle and management systems. If you do all this, then we will actually increase GDP. We will not lose GDP and we will not lose jobs. If we just import batteries, cells, materials, motors, chargers, power converters, and vehicle management system from either China or from Germany, then we will lose jobs and GDP. Today we are importing. So, for example, lithium-ion battery, it consists of 3 parts. First is a battery material. That is 40% of the value. Then there is a cell manufacturing, 30% of the value. And about 35% of the value is cell-to-pack manufacturing. Cell-to-pack manufacturing requires a very good thermal design at Indian temperature and driving condition, so that it can withstand 45 and probably 48 degrees centigrade. I'm talking Jaipur will see in 2-3 months that temperature. The cell-to-pack design also requires a very careful mechanical design, because the cells are such that when you discharge the cells tend to puff. So you have to put enough pressure though so that it do not bulge. If it bulges, the life of the cells will go down. If it gets over compressed, you put it too much of pressure, once again life of the cells goes down. So mechanical design has to be very carefully done. Electrical design has to be very carefully done, because most of these batteries are carrying large current, 200 amperes. Even a milliohm of difference between 2 parts may mean 0.2 volt difference, and 0.2 volt may appear that the cells are empty rather than full. So you have to worry about it. And then finally, you have to worry about battery management system to get the best out of each cell and to see that safety is not violated. Otherwise, without that, the life becomes very, very bad. Cell manufacturing is a technology which changes every 2 years. So it's an expensive technology. To set up cell manufacturing, you require several thousand crore rupees. Need technology which stays ahead in energy density. This is something that we do not have. But recently, a PLI has come, production link incentive of several thousand crore. So there are people who are bidding and who will bring the technology from outside, will do a tie-up from outside and bring cell manufacturing. Of course, tomorrow we have to do R&D, such that next generation and the next generation, we are able to do it on our own. Battery material is another important thing, it's mostly imported. And I'll talk about battery material. So battery pack manufacturing involves large number of components, large number of ancillary industry, large number of jobs. So I'm just giving you a picture of the number of components that are required. If you manufacture each of these components, design them, do quality thermal design, quality mechanical design, there is no reason why our GDP will go lost. Then materials for the batteries. Batteries today use lithium, cobalt, manganese, nickel, and graphite. We don't have most of these materials. And we will be importing, if we just import this, we do not have much of the mines. We will require 25 gigawatt hour by 2025, and our import bills can skyrocket. What is the answer to that? Recycle used battery. Once the battery becomes useless, you start with the recycling of cell phone batteries. Cell phone batteries are LCO batteries. Lithium, cobalt is there. We throw away 300 million cell phone batteries every year. We take that and recover lithium, cobalt, nickel, manganese, and graphite. And we can do it with near zero effluent, so that no wastage, no effluents are there. We can create huge number of jobs. Every battery needs to be recycled. Technology is available in India, and we can do that. In fact, India could import used lithium-ion battery and become an urban mining capital of the world. This will generate jobs. This is what India needs to do. If any one of you visit IIT Madras Research Park, you will see how we design batteries, how we design motors and controllers, how do you do battery recycling, and how do we design chargers. The next, similarly, motor and controllers. If you import all motors and controllers either from Germany or from China, as is being done today by almost every vehicle manufacturer, then of course our GDP will be impacted, jobs will be impacted. But if you see the number of components that goes in a motor is 35 to 40 components, and in a controller many components goes. If you manufacture each and every them, and all of this is doable, this is what we are doing. Within 25 kilometers in Chennai, we are able to manufacture every component of the motor. Controller we import, ICs, every other component we manufacture. Then we can generate enough job. Well, I would like to close my talk and open things to question and answer. Possible to make two-wheeler, three-wheeler affordable today. Today, with of course the subsidy, even without subsidy. Four-wheeler will take a few more years, but only 2-3 more years. It's getting there. Swapping, charging and swapping should become profitable. Swapping will help things move even faster. What is most important in India needs to design, develop and manufacture full drivetrain, battery packs, cells, recycle battery, motors, DC-DC converters, charger and vehicle converters plus all kind of vehicles. Time is of essence. If we don't do it in 3 years, we will be flooded with imported EVs and subsystems. Can we do it by 2030? I think certainly. And I've given reference to some of my articles out here. Those of you who want the copy of my presentation need to write me a mail. This is my last slide, so I will go back to my first slide. My email ID is given there, ashok@tenet.res.in. ashok@tenet.res.in. And now I am ready for questions and answers, and I'm going to stop sharing, and on the chat box I'll put my email ID. You can ask me any questions, sir.
Thank you very much, sir, for the wonderful speech explaining each and every issue on this, including the GDP part. It was a new thing for us. We were wondering whether we will lose the jobs in India because a lot of parts will be lost and component manufacturers will lose their jobs in India. Now that you have explained everything, we are sure everyone will be agreeing to you what is required for the EV to promote. Now we have some questions in chat box, and I will read one by one and request you to answer. First is from Rajendra Bhanawat Saab. Sir, what is the life of a battery if it is packed, it is fast charged and slow charges? That is his question.
So what's the question? Let me see. Let me myself go through the chat box. And
Ashok, if you permit, I can just
please,
say the
please.
question. The question is, you have mentioned in your talk that the life of the battery is dependent on the rate of charging the battery, whether it is a fast charge or a slow charge. So if it is, so in both cases, say whether if it is slow charge, what is the life of a battery at present, and if it is charged in a faster mode, what is the life of a battery? So that was just a question which came to my mind.
Sure. So it depends on the cells that you select. You today typically for a three-wheeler, even four-wheeler, three-wheeler, two-wheeler, you typically design for 1200 cycles. So that will be roughly about 4 years for slow charge. If you start doing fast charge, the same battery, it will probably last 6 months.
Okay, so eight times is the difference.
No, 6 times, 7 times. It depends. If you charge this to only once in a month fast charge, then probably life will still come down to 70. From 1200, it will come to 800, but it will not go to 200.
And how much does it cost, by the way?
Battery 1 kilowatt hour, suppose you buy a 2 kilowatt hour battery, it will cost you about 35, no, slightly more. Yeah, 35,000 rupees. 35,000 for the 1200 cycles battery. If you want to fast charge, the same battery will cost you 55,000, 60,000 rupees.
Right.
So you don't want fast charge. You will prefer charging in the night.
But I think, Professor Jhunjhunwala, the Indians will have to change the mindset of owning a big car, particularly which is happening these days all around, and being able to use the public transport more and more, because as you have said,
Sir, only 2% of the all the vehicles is a big cars. So I think rich people will buy that. You can't afford it. I think most of us will do small cars.
No, what
Most of us, I presume most of us are have been okay. There are rich people who will buy large cars. I don't want to comment on that.
The next question is by Satish Mathur Saab.
Only sir.
Satish Mathur Saab. Satish Mathur Saab. Put your question. Chat box में क्या है बोलो? Satish Mathur Saab. Unmute करें. चलिए.
Okay, now you are hearing my voice?
Yeah.
Yes.
Sir, I heard your recent presentation. I want to know that problem is frequent charging of the batteries. One of the problem in electrical way is frequent charging of the batteries. So I want to know, can we put a solar panel on the roof of the car or a bus, so that when it remain in the parking lot in an office or factory for about 4 or 5 hours, the solar panel can charge the battery? It is my question.
Yes, sir. Today, the efficiency of solar cell is about 21 to 22%. With that, in a typical car, if you put the solar panel, not only the cost will go up, it will, and if you keep it for 4 hours, even if it is, let's say, full sun is coming and hitting it, there may be shade and all that, it will only give you 10% charge. Now, if this efficiency goes to 40, 50%, then maybe it is thought meaningful. Today, it is not a meaningful thing.
Thank you, sir.
Sir, I have a question. I'm calling from Bangalore.
Next question from Rupesh. From chat box, sir. Can you see the chat box, sir?
Sir, can I?
Yeah.
Can I ask a question, sir?
Yeah, please go ahead.
So, are you hearing?
Yeah.
Yes, sir. Please go ahead.
Sir, since the efficiency of the battery is very much dependent on the fast charging and slow charging, and the battery deteriorates with fast charging. So swapping of the battery will it be possible? Because if you are giving your good battery and you are getting a bad battery, or your battery is fast charged and you just want to replace it from the other battery, then
No,
the
sir,
quality
I'll
of
answer this question. First thing is life of the battery, not the efficiency. Life of the battery is affected, not the efficiency by fast charge and slow charge. Now, in a swapping, you will not own the battery at all. Let us say a BPCL owns the battery. I'm just taking an example. So you will go to a BPCL petrol pump and get the battery. And when you want to swap, you will give it back to the BPCL or any BPCL petrol pump and take their battery. Battery will always belong to them. And they will never fast charge, because they will take the battery, put it in an air-conditioned environment and charge in about 3 hours. Once you charge in 3 hours, the life of the battery will be good.
I understand, sir, but only thing is that BPCL people will take BPCL battery only.
Yes. So what you do, just like SIM card, you buy a Reliance Jio, then you can make call with it. Similarly, you have to tie up with one of the battery
Yes,
swapping providers. It could
equally
be
equally
BPCL, it could be
reputed.
HPCL, could be
Yes.
ABC. They will have
Equally reputed brands should be there.
same.
And if I take a battery from BPCL and charge it at my home,
You cannot. So the battery will be designed so it can only be charged by BPCL battery and only be discharged by BPCL.
okay, means I have to depend
They,
on the
they,
BPCL.
they will put blockchain into that.
Achha.
They
In
cannot-
that
they cannot
case,
get to.
everywhere I will have to have that battery swapping
But if
session.
you do, it's like your petrol pump. Every BPCL petrol pump, suppose it has, there's no problem.
Yes. So
Thank you, sir. We have Dr. Raj Modi from USA. He's saying that Israel has swapping successfully. Israel has been using swapping for quite some time.
The swapping has been going on more in this thing in Taiwan and in India. These are two lead countries in swapping. We have been swapping battery for 5 years.
We have been swapping. Israel also for swapping?
Israel tried it, gave it up.
Give it. So we have AK Bohra Saab from Jaipur. AK Bohra Saab?
Remember once again, if you are a rich country, you will not swap. You will buy bigger battery. Like Tesla has a car with 600 kilometers. When you don't mind spending 50 lakhs or 60 lakhs rupees for a car, why will you buy a? But if you want a 6 lakhs rupees car, which in India we will get 5 lakh rupees car, then large battery cannot be done.
Good evening, sir.
Sir, AK Bohra Saab?
Yeah.
Please.
Good evening, sir.
Namaskar.
My question is, by purchasing a EV vehicle, we are doing away with the IC engine, isn't it? So, you compared the fuel tank with the battery weight only, but will it be much heavier, even heavier than the IC engine plus battery?
Yes, much more heavier.
Okay.
Battery is a heavy. See, ICE engine you will replace by electric engine, motors, controller, charger. That will slightly reduce the weight.
Okay.
But fuel tank, even when the fuel is filled up, is not very heavy. On the other hand, battery is much more heavy.
Thank you.
Sanjeev Jain, Mr. Sanjeev Jain is there? Sanjeev Jain साहब पूछिए अपना प्रश्न.
Good evening, sir.
Namaskar.
Sir, I am Sanjeev Jain, Chief Engineer from the Renewable Energy Development Agency, Chhattisgarh, जो कि MNRE की स्टेट एजेंसी फॉर RE इम्प्लीमेंटेशन. रिसेंटली हमको ये जिम्मा भी दिया है कि हम स्टेट में ई मोबिलिटी को बढ़ावा दें. उसी के तहत हमने ऑलरेडी एक गाड़ी खरीद रखी है सर, ई वेरिटो. जैसा आप बता रहे थे कि सर की बैटरीज में जो कार में जो बैटरी है उसको अगर फास्ट चार्ज करना है तो फास्ट कर सकते हैं और स्लो करना है तो स्लो भी कर सकते हैं. मेरी बैटरीज में ई वेरिटो में जो महिंद्रा ने जो कार दी है और जो चार्जर दिया है एक्सीकॉम का, उसमें दोनों ऑप्शन है सर. तो मैं ये जानना चाहूंगा कि व्हाट शुड प्रिफर, फास्ट और स्लो, बिकॉज उसमें दोनों ऑप्शन है. एंड मेरा ये एक्सपीरियंस है सर कि 100 किलोवाट के लिए मुझे लगभग 8 से 10 यूनिट बिजली लगती है दोनों मोड में, लगभग फास्ट एंड स्लो चार्ज में. और फास्ट चार्जिंग में मेरी 45 मिनट से के आसपास, 1 घंटे के आसपास चार्ज हो जाती है और स्लो में करीब 5 से 6 घंटे. तो मैं ये जानना चाहूंगा कि सर
संजू जी, ये कार, मैं महिंद्रा के बोर्ड में था जब ये कार बनी थी. मैं उनके टेक्नोलॉजी कमेटी का चेयरमैन था, तो मेरे देखरेख में ये कार बनी थी. मैं इसको 7 साल से चला रहा हूँ. तो इस ई वेरिटी को मैं बहुत बढ़िया से जानता हूँ. तो आपको नॉर्मली स्लो चार्ज करना चाहिए और रात को चार्ज करना चाहिए.
राइट.
नॉर्मली
जी.
हाँ, वो 5-6 घंटा लगेगा. 100 किलोमीटर लगता है, 16 किलोमीटर 17 किलोमीटर 1 घंटे में चार्ज होता है. तो 6 घंटा में हो जाता है, 5:30 में भी हो जाता है.
बिल्कुल सर.
हाँ, जिस दिन आपको कहीं जरूरी कुछ करना हो, कहीं आप गए और आपका खत्म हो रहा है, उसी दिन खाली फास्ट चार्ज यूज कीजिए.
जी.
Now we'll take a
नहीं तो आपकी लाइफ बैटरी की लाइफ खराब हो जाएगी।
ओके,
मिस्टर B.R. जैन सर, B.R. जैन साहब।
हाँ, B.R. जैन भी, दीपक जी भी।
हाँ, अशोक, गुड इवनिंग, दिस इज बेने।
हाँ, अरे वाओ, व्हाट अ ग्रेट सरप्राइज।
अच्छा, मेरा क्वेरी ये है कि यू सजेस्टेड दैट इंडिया बिकम दैट लिथियम एक्सट्रैक्शन हब फ्रॉम लिथियम यूज्ड बैटरीज।
हाँ,
ये इज इट एनवायरमेंटली फ्रेंडली सजेशन?
yes, totally friendly. Near zero effluent. Near zero effluent. There is no effluent at all. I have set up the plant now at Research Park.
इसका लिथियम एक्सट्रैक्शन का?
Yeah, zero effluent. Near zero effluent.
No, it is not like something like lead extraction or
no, it is
e-waste extraction.
It is. There is no effluent, no gas, no liquid effluent, no solid effluent, and very, very minimal gaseous effluent.
Oh, nice. And by the way, let me introduce myself to everyone. I am B.R. Jain. I'm representing Engineering Council of India, and I happen to be a batchmate of Dr. Ashok Jhunjhunwala.
मेरे classmate हैं मेरे.
It's a great going for us that such a learned persons have coming in the webinar. We are really grateful, Jain Sahab, having seen you here. It's a good opportunity.
दीपक जी हाथ उठा रहे हैं.
Deepak ji, please.
Thank you very much.
Deepak Sahab. Deepak ji.
Yes, sir.
Please come.
Sir, this is Deepak Nandwana from Udaipur, Rajasthan.
Please.
सर, मैं सबसे पहले ये बात करना चाह रहा हूँ आपसे कि जैसा कि सर ने बताया था कि हम जो भी ईवी बना रहे हैं तो मोस्टली 90% केस में 100 किलोमीटर गाड़ी पर डे चलता है मैक्सिमम अपन ये एफिशिएंट।
15 minutes I'll call you. I'm in a meeting. Huh? Okay, no problem. Thank you, sir. Yeah, sorry, sir. Again, you have to repeat the question because a call came.
Okay, सर मैं कह रहा हूँ अपना जो भी गाड़ी चलता है जो जनरली सिटी में यूज होता है वो अप्रोक्सीमेट 50 से 100 किलोमीटर पर डे।
तो बहुत होता है। मैं तो चला रहा हूँ 7 साल में रोज के लिए तो बहुत।
बिल्कुल सर, बहुत हो गया सर। मैंने खुद ने अभी 4 महीने पहले 15 इलेक्ट्रिक स्कूटर बनाए सर। मैंने खुद ने बनाए और हमने असेंबलिंग किया। और कार में सर चूंकि हम लोग इलेक्ट्रिक स्कूटर में यदि कन्वर्जन किट लगाते हैं एक्टिवा वगैरह में तो वो हाइब्रिड सिस्टम हो जाता है जो पेट्रोल से भी चल जाएगा और इलेक्ट्रिक से भी चल जाएगा। सर कार की मोस्टली जो बैटरी अभी जो टाटा की कार आ रही है 13.5 लाख रुपए की 13.55 लाख रुपीस की, वही कार यदि हम छोटी कार लेते तो 5 से 6 लाख रुपए में कार आ जाती है। 100 किलोमीटर गाड़ी को चलाने के लिए 10 किलोवाट का बैटरी इनफ है। 10 किलोवाट बैटरी का प्राइस होता है अप्रोक्सीमेट 1 से 1.5 लाख रुपए और इसका जो कंट्रोलर और मोटर लगता है वो भी 1 से 1.5 लाख रुपए का है। मैक्सिमम प्राइस बता रहा हूँ सर, ये मैं जो मैंने मार्केट में घूम फिर के
करेक्ट बता रहे हैं। 100 किलोमीटर की कार आज बन सकती है 6 लाख में।
तो सर हम लोग इस पे इनोवेट क्यों नहीं करते कि 100 किलो एक हाइब्रिड कार बने।
हाइब्रिड सर आपका कॉस्ट बढ़ जाएगा। हाइब्रिड कॉस्ट बढ़ जाएगा, आपको दोनों इंजन लगानी पड़ेगी, पेट्रोल और ये। तो मैं हाइब्रिड के फेवर में नहीं हूँ। मैं रेंज एक्सटेंशन
सर मैं आपको बोलूंगा सर 5 लाख रुपए में नॉर्मल पेट्रोल की कार आ रही है 5 लाख रुपीस टू 6 लाख रुपीस में। तो
उसमें अगर आप डालेंगे 100 किलोमीटर की तो और 5-6 लाख बढ़ जाएगा।
नहीं सर 3.5 लाख रुपया बढ़ेगा, फिर भी 10 लाख रुपए में बढ़िया कार बन सकती है।
10-11 में बनेगा पर एक्चुअली
आपको बैटरी को स्वैप की हेलो
क्या तो बैटरी स्वैप कीजिए या 150 किलोमीटर की बैटरी बना दीजिए, उससे बेटर होगा। 150 किलोमीटर
हम 300 किलोमीटर का यदि बैटरी बनाते हैं ना सर
150
किलोमीटर का 150 का बनाते तो सर अप्रोक्सीमेट 2 लाख रुपए का।
नहीं 150 किलोमीटर की बैटरी बना लीजिए या 200 की बना लीजिए 8 लाख में
200 की बना ले
200 की 8 लाख में आ जाएगी। 10 लाख में
8 लाख बहुत बैटरी कॉस्ट
नहीं टोटल कार का दाम
बहुत ज्यादा है सर।
टोटल कार का दाम 8-9 लाख लगेगा
टोटल कार का।
हाँ 8-9 लाख में। तो हाइब्रिड से अच्छा तो वो हाइब्रिड को तो आप गवर्नमेंट ऑफ इंडिया नहीं चाहती है क्योंकि इट्स अ बैड अप्रोच.
Now the next question is from Yogendra Mangal ji. Yogendra Mangal sahab. Yogendra Mangal sahab. Sir Yogendra Mangal ji.
Yes. Good.
Please, please.
Am I audible, sir?
Yeah, please go ahead.
Yes, sir.
Sir, I have a very basic question that most of the time it is hard that the battery life, as long as the battery life goes down, that battery drains very fast. So how to overcome this?
Sir, yeah, go ahead.
Like we are talking about swapping of batteries now. Suppose someone gives me a battery of a poor quality, and it will.
Sir, I've told you that in battery swapping, battery will not be owned by you. So if
Yeah, it will be owned
BPCL
by
owns
the
a
supplier.
battery, BPCL can give you a
Right,
battery for 100-kilometer range. It can give you a battery at 80-kilometer range. It can give you a battery of 50-kilometer range. You can choose.
Okay, sir. So there is no question of poor battery or better battery.
It doesn't matter, sir, because they will tell you 80-kilometer range. If you are not going to go farther, take this. You have to pay less.
And now the last question from my side, sir. The last question is from my side. The government has announced 20% ethanol mixing in that petrol diesel. Your view on this, and similarly the retrofit system in the vehicle. What's your view on these two issues?
So let me start with first thing is ethanol mixing with petrol vehicle. While it may help us slightly reduce our import bill, but my feeling is it is not going to go far enough. Cost has already gone to $100 per barrel. It used to be $80. So their 20% has been wiped out already. So that is not a long-term option for me. It may be a short-term option for 4 or 5 years while the transition takes place. So I will say, whether we like it or not, world will move to electric vehicle. In 10-15 years, ICE vehicle will go away. So there is very little point in trying to do this. For a short-term measure, it can be thought of okay, but not for long-term. That was question number one. Question number two was?
By retrofit.
Yeah, I strongly support retrofit. You remove the, I am actually designed a complete retrofitting kit for a three-wheeler, for an auto. You remove the thing completely and put in electric, make it electric auto. I think I strongly support that. We have designed it. We are planning to sort of do that. I think it will be cost effective, and otherwise this older way, the autos will keep on polluting like anything. We can just completely change.
Now I will request President of the Rajasthan Solar Association, Mr. Sunil Bansal, who happened to be the president and very active in promoting the solar energy in state. He is about 200 members, like the big one also, Reliance and all, Adani and all, they are members of Rajasthan Solar Association. Sunil Bansal ji.
Yes, sir.
Please.
Yes, sir.
Give your words for that.
Thank you, sir. Thank you. What a great collection Samta Power have created, and I thanks Dr. Ashok Jhunjhunwala giving I think this is a unique presentation and wordings about the electric vehicle we have heard. You have done so many research, and we have seen, we have heard the things which are beyond our imagination till date. Definitely, electric vehicle is the new era of our mobility. and in coming days, we will see the unbelievable development in this sector. अशोक झुंझुनवाला ने जो एक बताया कि IIT मद्रास ने एक पूरा का पूरा रिसाइकलिंग का प्रोसेस भी वहां पे सेटअप किया है। बैटरी में हमें बैटरी पैक कैसे बनाना है उसके बारे में भी बताया है। ये एक बड़ा अपॉर्चुनिटी हम लोगों के लिए, MSME सेक्टर के लिए, सोलर एंटरप्रेन्योर्स के लिए भी, कि हम लोग वहां अगर ये अपॉर्चुनिटी मिले तो एक डेलीगेशन के रूप में जाना चाहिए और जाके ये सीखना चाहिए कि ये इलेक्ट्रिक व्हीकल के अंदर एक MSME सेक्टर के लिए क्या बिजनेस अपॉर्चुनिटीज हैं। ये एक आउटकम इस आज के डिस्कशन से निकल के आया है कि अल्टीमेटली अगर कोई भी नया टेक्नोलॉजिकल डेवलपमेंट होता है, जब तक वो एक आम आदमी को, एक एंटरप्रेन्योर्स को एक नेक्स्ट लेवल पे नहीं लेके जाए, it will be benefited to all over the MSME sector of the country. So this is the one way. Second, the manufacturing of the battery and cell. Cell is definitely a big industry. Mr. Jhunjhunwala have given comment on this in very detail. For the MSME sector, lots of battery manufacturing, packing, you can say pack of the battery. We can go clusters also. And the PLI scheme is definitely helpful for us. But as per my information, it is for only the big industries. That's why we have requested so many times to the MNRE and the Government of India to include the MSME needs, so that, because ultimately the development of the countries depend on the MSME development. Third point, which Mr. Jhunjhunwala emphasized, that the hybrid is not suggestible. But this is also a very good outcome of this talk, because we heard that the hybrid is the new era of this electric vehicle. But as per Mr. Jhunjhunwala, this is not the suggestible, this is not the advisable. This is also very important information for us. End of the day, end of this talk, I thanks Mr. Jhunjhunwala for giving this opportunity to learn these kind of insights of this industry. And I request to allow one delegation to IIT Madras of some of our industries to see and plan. One more thing, you have emphasized on recycling of lithium-ion batteries, lithium phosphate batteries. This is also very unbelievable, because we generally in these days finding the lithium ion batteries and lithium phosphate batteries are one challenge. If we not charge this battery for 1 month and 45 days, the battery will go down, permanently go down. If we have the recycling process that can be used again for our industry, this will be boon for this industry. Thanks, Mr. Jhunjhunwala, and giving me opportunity for to say something for Samta Power. Thank you, sir.
Thank you, sir. I'll disconnect, but I just want to once again invite you people. If any one of you want to come, please do. Second, please send me an email. I have given my email address in case you want the copy of the presentation or if you have any other question. Third, I think retrofitting to three-wheeler in particular could be a very good MSME business. I agree that the PLI schemes is all for very, very large companies. In fact, I don't know why I fought like anything in the government that make it for medium-sized businesses, but they have not agreed. They have really pushed it only for large business. That's unfortunate, but anyway, this retrofitting is a very good business. I think better than any of these things. Retrofitting, if we can learn, we can. This is not a very high investment business. That's a very good business. Thank you very much. I'll disconnect now. Thank you.
Thank you very much, sir. The concluding comments will be made by Rajendra Bhanawat Saab. He is a very senior IIS officer, retired, and he remained the MD of RICO. I would request Bhanawat Saab to just say Concluding comments, sir.
No, nothing much.
Just a small comment, sir, please. Because we are already over time, sir. We request you to kindly give the closing comments.
Thank you, Professor Jhunjhunwala, for an excellent presentation. It is whenever I have heard you once or twice earlier on this platform, and it is always a matter of, it is always an education for people like us who are novice or who are ignorant about this field, and then we try to know more and more. And the future, as you said, belongs to the electrical vehicle in India, and not only in India, all over the world. But the challenge is, as you have said, to bring down the cost, to bring down upgrade the efficiency, to reduce the load of this wastage, etc. And I think all of us have been highly educated now, and we can pass on this message to whatever places we talk about it. And I'm sure that we have learned. I have a few questions, but I'll send an email to you, and maybe others also will send an email to you to understand a bit more, to develop a greater clarity on whatever you have said. अच्छा लगा हम सबको. Thank you so much, and wish you all the success.
Samta Power की तरफ से धन्यवाद.
Thank you. I need to leave because मुझे और एक टॉक.
नहीं, thank you.
Thank you बोलिए साहब. आप सभी आगंतुकों का धन्यवाद देंगे. भाई के बोलिए सर. Thank you very much, sir. Thank you. भाई के बोलिए सर.
आज की डॉक्टर अशोक झुंझुनवाला साहब को करीब अपना 1.5 घंटा 2 घंटे स्पेयर करने के लिए मूल्यवान समय, और सभी करीब 80 के करीब लोग जुड़े अपने वेबिनार से. बहुत अच्छी स्ट्रेंथ जुड़ी है. इसमें इंजीनियर्स भी है, नॉन इंजीनियर्स भी हैं, जो सरल शब्दों में समझा, जो इंडस्ट्री वाले हैं जो फिटिंग करेंगे वो उन्होंने भी ज्वाइन किया. बहुत उपयोगी रहा. तो डॉक्टर अशोक झुंझुनवाला को और सबको बहुत बहुत धन्यवाद कि इस वेबिनार में भाग लिया, और आगे भी इसी तरह हमारे उसमें सहयोग करते रहे. बहुत बहुत धन्यवाद.
थैंक यू सर. गुड इवनिंग ऑल. मैं आखिर में आप सभी का बहुत बहुत धन्यवाद देता हूं कि आप सब लोगों ने पार्टिसिपेट किया, सबने ज्वाइन किया, अपने क्वेरी जानी. कुछ लोगों के हम क्वेश्चंस नहीं ले सके समय का अभाव होने से, तो we will try to get it through whatever questions you have put in chat box. We'll try to answer those questions through Shri Jhunjhunwala sahab. Please be sure that we will get some answers from him. आप लोगों का बहुत बहुत शुक्रिया, बहुत बहुत धन्यवाद. आप आए और आपने ज्वाइन किया. बस एक बार दोबारा से ये कहना चाहूंगा कि इलेक्ट्रिकल व्हीकल पे इन्होंने कोर्स डेवलप किया है नेपटेल के माध्यम से. वो फ्री है और ऑनलाइन है, तो उसमें अगर आप देखेंगे तो काफी बातें आपको क्वेश्चंस के आंसर्स मिल जाएंगे. मैंने देखा उस कोर्स को. इट्स रियली वंडरफुल कोर्स दे हैव डेवलप्ड. Such 955 courses they have developed. 955 with the national this enhancement of technical qualifications, and they also issue the e-certificate for that. It's an online course, and not only engineering subjects, but even the music is part of it. These courses are for many issues. Thank you very much once again, and काफी समय हो गया, आपका काफी समय लिया है, उसके लिए एक बार सबका बहुत बहुत धन्यवाद. और आप इसी तरह हमारी और वेबिनार्स में सम्मिलित होते रहेंगे. हम यही कोशिश कर रहे हैं कि अच्छे से अच्छे जो नॉन है, जो टेक्निकली बहुत क्वालिफाइड हैं, जिन्होंने इनोवेशंस में हैं, उनको हम बुलाएं और कुछ अवेयरनेस क्रिएट करें. समता पावर का यही रोल है, और उसी रोल को निभाते हुए हम आपसे अब इजाजत लेना चाहेंगे. सनाडे साहब और कुछ कहना चाहेंगे या समाप्त करें? काफी समय हो चुका है, इसलिए मेरा आपसे निवेदन है कि आप सनाडे साहब अनम्यूट करें साहब. अनम्यूट करें.
हाँ साहब,
समाप्त करें सर.
हेलो.
हाँ साहब बोले.
हाँ साहब,
अब समाप्त
ऐसा है कि बहुत अच्छा प्रोग्राम रहा. पूरा विदेश से, देश से और सभी क्षेत्र से लोगों ने भागीदारी की. और मेरा तो अंत में यही निवेदन है कि आप जिस तरह से भूमिका अदा कर रहे हैं वो भविष्य में भी करते रहें, ये मैं परमात्मा से प्रार्थना करता हूँ. और चौधरी साहब को भी देख रहा हूँ मैं, तिरानिया जी को भी, उनकी भी कृपा बनी रहे. और आप सभी को बहुत बहुत धन्यवाद.
धन्यवाद सर. Thank you everyone. Thank you once again everyone.
Thank you.
राजू क्या